Hey guys, welcome back to Infinite Insight Geometry. Today we'll be looking at lesson 1.1, inductive versus deductive reasoning. Alright, let's begin. So, we're given a triangle, a square, a pentagon, and a hexagon. What shape do you think comes next? Well, I would say that the triangle has 3 sides, the square has 4 sides, the pentagon has 5 sides, and the hexagon has 6 sides. So the correct answer here would be a heptagon, right? Would you say so? But that's the thing. We predicted it. Did we actually prove it? Are we sure this is the correct shape that comes next in the pattern? You know, it could be something else entirely. It could be an octagon. Could be a dodecagon. Could be anything else. Could be a star. We don't really know the pattern here. Of course, the pattern probably is that you're adding one side each time. But how do we know that that's really the pattern and then the next shape is really a heptagon? To do that, we use inductive and deductive reasoning. Now, inductive reasoning we just use to get the heptagon. It's logical reasoning of data to make general observations and patterns. We make predictions about what happens next based on the patterns of the data that we're given. But since we don't have any actual proof that this is the pattern, we aren't actually entirely sure whether that is the correct scenario. So that's a problem. For example, prime numbers 2, 3, 5, 7, 11, 13, 17, they're all odd numbers except 2. We have all of these odd numbers. So we can use inductive reasoning. We can use these examples to show that all prime numbers are greater than 2 are odd numbers. 3, 5, 7, 11, 13, 7. They're all odd numbers. But did we actually prove it? Because last I checked, the prime numbers go all the way to infinity. And if we're given all of these examples, then shouldn't we make sure that all of the examples are odd numbers to prove this statement true? That's the problem with inductive reasoning. It's prediction. And mathematics isn't about prediction. Well, some of it is, but in geometry, we're more focused on logic and proofs. And that's used by deductive reasoning. We use deductive reasoning to make logical reasoning of data to make absolute facts. We make absolute certain that that is the scenario. So let's go back to our problem. Are all odd numbers greater than 2? Are all prime numbers greater than 2 odd numbers? Well, we can write any even number in the form of 2n, where n is an integer. For example, 2 is 2 times 1, 4 is 2 times 2, etc. But since 2n will always be divisible by 2, that makes them composite, meaning that all prime numbers greater than 2 must be odd. That's how we prove that every prime number greater than 2 must be odd, because any even number greater than 2 is composite instead of prime. So, let's take an example. A guy notices that the sun rises every morning when he wakes up. He then concludes that the sun will rise tomorrow morning. Is this inductive or deductive reasoning? Well, I would say that that is a very good example because you don't actually know whether the sun will rise up tomorrow morning. You're just given examples of the past days. The sun rises every morning. And then you're making a prediction that the sun will rise again tomorrow morning. But you can't actually prove it using those examples. What if the sun doesn't rise up tomorrow morning? This is inductive reasoning. He makes a prediction, but he doesn't use absolute reasoning to make his conclusions. But this is a good example of deductive reasoning. If all humans are mortal and I am a human, then I am mortal. This is deductive reasoning. Because if not all humans were mortal, then this logic would not function properly. We are given that every human must be mortal. And I am a human. I know I'm a human. I hope I am a human. And so, by this logic, I am mortal. So, this is a very good example of deductive reasoning. So, that will be all for today's lesson. Please like, subscribe, and comment down below. If you have any questions, my Gmail is always up. And I will see you next time.